Hey guys, so before we get into the next part of chapter 1 called reporting with precision and accuracy, we're going to go over the last video with one example. So in this example, it says that during a cycling event for charity, Amanda traveled 105 kilometers in 4.2 hours. And Brenda, so this was A. We're just going to call her A, Amanda. And Brenda traveled at the rate of 0.2 miles per minute. So this is Brenda. So now we're going to say, which girl traveled faster? So remember, it says right here, 1 mile is equal to 1.61 kilometers. So we're going to compare these two. That's the point of this question. So in order to do this, we have to set up the equations to where we're converting each of these factors into the same factor. So this is 1.2. I'm so sorry. So that's what we're going to do. So since this is 1.2 per minute, we are just going to take this kilometers and convert it to miles because we don't know how long Brenda went. We just know how long Amanda went, so it might be easier for us to do it that way. So first, we're going to figure out how many minutes are in a mile. How many minutes are in 4.2 hours? So 4.2 hours, right? Multiply it. In 1 hour, how many minutes are there? 60. So the answer to that is 252 minutes. Next, what we have to do is we have to convert. So all we did here, remember, we're just canceling out these two factors, so we're left with only minutes. So we have 252 minutes, right? So, but we don't know how many miles Amanda went, or A went. So what we're going to do for that is 105 is how much it said that Amanda biked. So we're going to do, that was bad. Okay, we're going to do 105 kilometers. We're converting it to miles. So in this case, instead of doing 1 mile at the bottom and 1.61 as written over here, instead of doing that at the bottom, we're going to do the 1.61 at the bottom. So 1.61 kilometers goes for a mile. So now, what is that equal to? Around 65.22. We'll just keep it at 65. Actually, 22 is cool. Okay, cool. Now, we have to figure out how many miles did Brenda go. So now that we know that there was 252 minutes in that, we can just compare it easily. So she's saying she did 0.2 miles per minute. So all we're going to do here is 252 times 0.2 times. Because this is the miles, so it'll tell you how many miles she went in 252 minutes. She only went 50.4. So now we're going to create the equation A, B, and what was A? 65. And 50.4. Now we just need to figure out. So we're comparing them. So what happened between them? So who was faster, who was slower? As you can clearly tell by these numbers, Amanda was faster. So, conclusion. That's the conclusion. That was the same thing we did in the last one, except it was a little bit more work, but I guess it was worth it if you learned the material. So, okay, now we're going to go for the accuracy and precision. So the difference between precision and accuracy is precision is just the level of measurement. So it's like the smallest unit, the smallest fraction. But accuracy is the closeness. So the difference is precision's like how reasonably is it measured. So like the closeness is the value where it's much closer to the actual value. So in this, the question, this is just an example I see in the book. So the question is, Sarah wants to paint a wall. The length and width of the wall are 2 meters, 2 meters and 1.4 meters. So all we have to do is calculate the minimum and maximum possible areas. So this right here is the length. And this right here is the width. So as it says in the textbook, I'm going by the textbook entirely, so you can just follow along with me if you have this similar textbook. It's from the Texas Harcourt Mifflin. So basically, what's happening is to find the minimum, all you have to do is, so precision is between 0.5-ish units, you know? So the minimum width can actually be between, so as of the minimum width would be 1.4 minus 0.05. And this one would be 2 minus 0.05. So first we're going to find the values of the minimum length and the minimum width, because precision and accuracy are obviously not on the exact point of the, like, what you're measuring. So you can just subtract or add, it's like give or take, you know? So 1.4 right here is going to turn into 1.35. And this is going to turn into 1.95. So respectively, these could be the minimum values of the length and width. So now you're just going to find the minimum values of the areas. So we're going to do 1.95 times 1.35. Remember, this is all minimum. Let me just write it up here. Okay, so this is all minimum, and this is just equivalent to 2.63. So this is the minimum, but now we have to find the maximum. So for the length, it'll be 2 plus 0.05. And for the width, it'll be 1.4 plus 0.05. Because you're adding, so it like maximizes the entire thing, you know? So 2.05, and this will go to 1.45. So now, all we're going to do, same thing as before, just multiply these two values, and it'll give you 2.97. So this is the max. So you can say now that the area of this room is relatively between 2.63 to x. All this x value means is that the number of the actual area of the walls are can be between this and this number, and it can even be these numbers, which is why I've included these lines below to include 2.63, because that can be a minimum, or 2.97 can be a minimum. So yes. Next, we're going to do another example. Similar, except we're just doing it with a garden. So in this example, we're going to do 15 feet by 2.7 feet. So we're just finding the area, very straightforward. So let's say this is the, it's like accuracy, or it's like precision, right? So we're not going to say these are the actual values of the garden plot. Instead, we're just going to add 0.05. We'll do maximum first. And same thing on this side. And then you multiply these two numbers to give you 15.05 times 22.75, which will give you around 342.4. We'll round it to one decimal place. Same thing. This is the maximum right here. So we're going to do minimum. Instead, 14.95 and 22.65. All I did was, instead of adding like I did up here, I just subtracted it, like the other example. And that'll give you 338.6. We actually need two values here. I don't know why I put it at 1, so it's 38 here, and this will go to 61. Oops. Sorry. 61 right here. So all we know now is that the plot has to be in an area between 61 and 342.38. Okay, this is it for today's video, so thank you guys so much. I hope you have a wonderful day, and I'll see you next time.